Right. Good day once more, good people. Today, I would like us to look at the Beckmann rearrangement. That is at the Beckmann rearrangement. Now, how does this rearrangement actually take place? Right. First, what I'm showing here, I am showing you two reactions. Right. First, that is whereby I form the starting material that is required in the Beckmann reaction, which is the oxime. Né? How is this oxime that becomes a starting material for the Beckmann arrangement? How is it made? First, you have your carbonyl compound. Your carbonyl compound is mainly treated with your hydroxyl amine. It is treated with what? With hydroxyl amine, right? Then to generate an oxime. So as you can see here, now like you've got a C, which is double bonded to oxygen here, and then here you've got your C, which is double bonded to what? To nitrogen, like here, and your OH that side, isn't it? This structure is your oxime. Once you've prepared your oxime, then you can treat your oxime, right, with H plus in the presence of heat to generate an amide. In that case now, like you are going to have what we refer as, the actual Beckmann rearrangement. I'll show you like when we look at the mechanism of that second part, right? How this actually happens in the reaction. Now I would like us to look at the mechanism of the very first step. So if we look at the mechanism of this first part, I'll just refer to this as the first part of this action. So what happens here is you start off with your carbonyl compound. There's your carbonyl compound. This is bonded to R. This is bonded to R prime. This react with your amine. There's your amine, your hydroxyl what? Amine. There we go. There we go. So this amine here, it is here as a nucleophile. So where is it going to attack here? Remember here you've got your carbonyl carbon atom here and your carbonyl oxygen atom here. Oxygen is much more electronegative than carbon, and therefore it pulls the electron density towards itself, and thus it becomes what? Nucleophilic. Whilst the carbon atom remains what? Electrophilic. Meaning that it can easily be attacked by what? By a nucleophile. So this is where the nucleophile is going to attack. As soon as this nitrogen brings its electrons here, then these ones, they pull out. What do you generate that side? You generate O, that is what? Negative in charge. Bonded to carbon this side. This is bonded to R. This is bonded to R prime. This carbon atom now is bonded to nitrogen. Nitrogen comes in here with two hydrogens and what? And an OH group. That side. So nitrogen was what in charge? Neutral. And therefore nitrogen is going to become what in charge here? Positive. Nitrogen is going to become what? Positive. In terms of what? Of charge here. There's our oxygen, nitrogen. Now what happens here is that now like your nitrogen, it takes away the bond pair that it shared with hydrogen. As hydrogen falls off as H plus, it is picked up by that O minus, that side. Then what then do we form here? We generate this structure here now. This is our R, this is our carbon, this is our R prime, this is our OH, 1, 2, 1, 2. We've generated an OH group now in that position. Then here, what do we have here now? Like we have our nitrogen bonded to hydrogen, bonded to OH this side, and a lone pair on that nitrogen that side. Now what's going to happen here now is that now like the OH group that we have there now like is a bad living group. In order for it to be able to live, it needs to be protonated, right? How is it going to be protonated? This OH group will pick up this H plus, and the H plus will leave behind the bond pair that it shared with nitrogen to generate a structure like this one now here. We generate, in that case, O bonded to H with only one lone pair bonded to carbon, bonded to R prime, bonded to nitrogen. Lone pair the side, lone pair the side. Now there's going to be a negative charge on this nitrogen. This is bonded to OH that side. There you go. Now the oxygen there, here, it was neutral in charge. It has picked up a proton. Therefore it becomes what in charge? It becomes positive. We've got water, that is positive. Then water becomes a good living group. Water becomes a good what? Living group. What then do we generate in this case now? We generate this here, that here. There's our R, there's our R prime. This is N, 1, 2, 1, 2, negative. Then this is our OH, that side. Right? Now, there's our positive charge on the nitrogen, what call like atom. Right? Remember, you've got your nitrogen that is negative here. And then this here now like brings in, right, to form our oxime in this case. There we go, there we go. This is R prime, C, which is doubly bonded to what now? To N, singly bonded to what? To OH. There we go in that case. Now, we are only left with one lone pair in that case, right? Right? And then now like this is our oxime. So this is how we have formed our oxime. This oxime becomes the starting material now for the what? For our Beckmann, what call like rearrangement. I'll show you the Beckmann, what call like rearrangement like in our what call like in our next what call like class, because I'm not going to have what call like space here now. I'll show you like in the next class. Right? Just hold on. I'll see you in the next class. Thank you for what call like for listening. I'll see you soon. Just now. Thank you.